Hi all, my name is Pradyumna. I am here to talk about understanding fragmentation in operating systems. Fragmentation occurs when data is scattered non-contiguously in memory or storage. Think of a disorganized bookshelf versus a well-organized one. This leads to a slower performance, reduced efficiency, and system instability. Fragmentation is a challenge for operating systems. What is external fragmentation? Let's talk about it. What is the definition of it? Sufficient total memory exists, but it is not contiguous. Mark the words. Cause dynamic allocation, deallocation of memory blocks. Let's take an example. Process A, process B, process C. 2 MB, 4 MB, and 2 MB. Deallocated 4 MB free, but process G 3 MB can't be allocated. Mitigation, compaction, paging, and segmentation. External fragmentation is when enough total memory is available but not a contiguous block. Mitigation techniques includes compaction, paging, and segmentation. This type of fragmentation possesses challenges for memory managers. What is internal fragmentation? The definition of it. Allocated memory block is larger than required. Cause fixed size allocation units leading to a wasted space within a block. Example, allocating a 4 KB block to a 1 KB file wastes 3 KB, obviously. Mitigation, dynamic allocation, better block sizing strategies. Internal fragmentation occurs when the allocated memory is larger than needed, wasting space. Mitigation strategies include dynamic allocation and optimized block sizing. This is the common with fixed size allocation schemes. File system operation cause fragmentation. Basically, there are 4 steps in this: creation, deletion, and modification of files over time. Second one is small files scattered across the disk. Frequent overwrites of existing files and database files growing, shrinking dynamically. File system operations such as creating, deleting, and modifying files cause fragmentation. Small files and frequent overwrites exacerbate the issue. Dynamic database files into also contributes to this problem. Memory management causes fragmentation. Dynamic allocation. Dynamic memory allocation in RAM will need. Process lifecycle. Processes requesting and realizing memory at different times. Memory leaks. Memory leaks exacerbate at the problem. Dynamic memory allocation and the life cycle of processes contribute to fragmentation and RAM. Memory leaks further worsen the situation. These factors lead to insufficient memory usage over time. Performance degradation from fragmentation. First, second, and third, there is a pyramid-like structure in this. First, which slows the app. Second, sluggish system, and increased I input and output. Fragmentation increases disk input and output, slowing application loading times. The system becomes sluggish and unresponsive. Application loading time can increase significantly, significant, reduce storage efficiency from fragmentation. Application loading time can increase significantly. Reduce storage efficiency from fragmentation. 20% storage capacity loss due to fragmentation. Limits the amount of data that can be stored. Increased wear and tear on storage devices. Fragmentation leads to wasted space and limits the amount of data that can be stored. It also increases wear and tear on storage devices. Defragmentation. Let's talk about what is the types of defragmentation. Reorganize. Reorganizing files to occupy contiguous storage blocks. Second one is consolidate. Consolidating free space to reduce external fragmentation. Tools. Online versus offline defragmentation tools. Defragmentation reorganizes files and consolidates free space. Tools include Windows defrag and Linux defrag outlets. Utilities. Choose the right defragmentation approach. Memory compaction and optimization. First is compaction, moving process in memory to create contiguous free space. Second is paging or segmentation, utilizing memory management techniques like paging and segmentation. Maintenance, regular system maintenance and optimization. Memory compaction moves processes to create contiguous free space. segmentation, paging or segmentation, and regular maintenance optimize memory allocation. Managing fragmentation. First is proactive measures. We have to choose appropriate file systems and monitor disk usage. Second is regular defrag. Schedule defrag tasks, use efficient defragmentation tools. Third is memory management. Optimize memory allocation, which prevents memory leaks. Fragmentation is inevitable, but manageable. Take proactive measures, schedule defrag tasks, and optimize memory allocation. Preventing memory leaks is also critical for maintaining system performance. Thank you so much.